Hello everyone, welcome back to my channel. In this video, I will quickly introduce you to VASP. VASP is among those quantum chemistry codes which calculate the quantum mechanics properties of materials ab initio. And there are really a lot of quantum chemistry codes, including quantum espresso, Orca, Vin2K, etc. Some of them are free, like quantum espresso. Some of them are academic, like Orca, which means that you can get a free version if you do research, and some of them are commercial, like Gaussian and VASP. On the right hand side, there is this popularity of different DFT codes, and you see that VASP is surely the most popular one. However, you shouldn't be afraid to use those codes that are not as popular as VASP, because all of the modern DFT codes give consistent results shown in the paper on the right hand side. That is a paper in Science magazine in 2016 that the author confirmed the reproducibility of different DFT codes. So in my channel, I have covered the tutorials for quantum espresso and Orca, and in this tutorial I would like to cover VASP. If you want to do quantum mechanics calculation, you need to project your wave function into a basis. And there are two popular basis set. One is the plane wave set, which means that you project your wave function with a lot of plane waves. This is something like the Fourier transform in mathematics. One problem of this projection is shown on the right hand side. You see that this is the Coulomb potential, and the real wave function would look like this. Near the core there are a lot of oscillations, and the more nodes you have, the higher order Fourier modes you need to keep, which means that you need a very large set of plane wave to construct a full wave function. However, most of the low energy physics, including the bonding, the chemical reaction, happens on the outer shell electrons, or let's say the valence electrons. So people invented the pseudopotential method, which means that they construct a potential that is exact outside of the cutoff radius, but it's fake inside the cutoff radius, which results in a pseudo wave function that is accurate outside of the cutoff radius, but is much smoother inside. And this smoother pseudo wave function will require lower Fourier modes, which makes plane wave expansion more easy to implement. And you can see that there is some freedom in constructing the pseudopotentials, which results in the different types of pseudopotentials, like the norm conserving, ultra soft, and PAW. For quantum espresso, you have all these three or different kinds of pseudopotentials, but in VASP now you only have PAW. I think in the old version you have USPP, but now in the new version you only have PAW type, because they think that this is the best. The quantum chemistry codes that uses plane wave basis includes quantum espresso, VASP, Abinit, CASTEP, and they are the favorite for solid state physics, because plane wave basis is naturally suitable for periodic boundary conditions. Another choice of basis set is local orbital. This is something like the tight binding approximation, where you approximate the wave function by the combination of local orbitals. The quantum chemistry codes that uses this kind of basis set includes Orca, Gaussian, and Siesta. They are usually the favorite of chemists, because they usually deal with isolated systems. However, it is not really so different, because you can use the packages with local orbital to calculate solids as well. You can also use the plane wave basis codes to calculate the molecules, because you can just put the molecule inside a box. And then let's go back to VASP. VASP contains the main program, and in the old versions it is divided as a main code and math library, and in the new version it is compressed to a single file. And apart from the main program, you also get a pseudopotential library in the distribution, and in the new version it is only of a PAW type, but you can find pseudopotential library for different functionals like LDA, GGA, and PBE. And note that the pseudopotential library here is commercial, it is under copyright, you cannot distribute everywhere, and you can also not download it from the internet freely, unlike Quantum Espresso. But the nice thing is that the pseudopotential library is well maintained, so you don't have to search for a good pseudopotential, because the one that comes from VASP is a really good one. And VASP also comes with some tools. One thing that you need to choose before your calculation in DFT is the exchange functional. For example, LDA, GGA, PBE. So LDA means local density approximations, and if you go further to and include gradient, you have the GGA. And PBE is one type of GGA that is commonly used in solids. And you can go further to meta GGA, or you include Hartree-Fock plus DFT, then it's hybrid functional. You can also include van der Waals interaction with DFT. Yeah. So in this video, I just quickly show you the quantum chemistry codes like VASP, and what is the structure of VASP, and what is the exchange functionals, pseudopotentials. And if you want to know more about one of the topics, I advise you to find some courses or videos and that go into more details in that direction. And in the next video, I will go to the details of VASP, including the input files, and there are basically 4 input files of VASP in-car, post-car, K-points, and pod-car. And I will also show you the output files for VASP. So if you learned something from my video, I would appreciate your like or subscribe to my channel, and I hope to see you next time.